All right, hi everybody. Welcome to your podcast on the scientific method. So I have this picture on our first slide, and it's very similar to a poster that I have in my classroom. And both of these things, label them as the scientific method. And it's got all these little steps, almost like you could go through each one of these and put a check mark by them when you're done. And that's where I have a problem at. This seems like it's a very linear progression. And not to scare you with little math, linear just means it kind of moves in a line. And although the steps do kind of follow a sequence, there's something that's missing from the scientific method, and that's in this picture right here. And that's what I want to explain to you in today's lesson. So if you're following along in your packet, you will find on the scientific method pages, you do have something that looks like this. And you can kind of see that there does look like to be some steps involved, but what's interesting is the order of those steps and the arrow. So if you're in your packet, you're going to see this exact same picture on page 15. And you could even fill in these parts on page 15, and that'll help you out. So the beginning of this is exactly how we started our class here in biology. The beginning of the scientific method usually revolves around some sort of observation that you make. So we're going to fill in here that you make observations. And remember, at any point as I'm filling this in, if I'm going too fast, just hit pause so that you can catch up. All right, remember, those observations could be part of your senses. Oops. Or they could be number values that you come up with. So that's qualitative and quantitative. Now, oftentimes when you make these observations, and let's say, for example, you smell a flower and it smells sweet, well, how do you know that, something that smells sweet smells that particular way? Well, you always consult your prior knowledge. You always try to fill in what you already know and what might be new to you. So that's another part of this that's pretty major, both your observations and your prior knowledge. And so after you make your observations, after you kind of think about them a little bit, like, have I seen this pattern before? How do I know that this exists? That's what really helps you to formulate your hypothesis. All right, you'll have to bear with me as I learn how to use my little writing pad here, but that does say formulate hypothesis. Now here's where our steps seem very similar from that last picture that I showed you. Let's look over here. So far, we've kind of asked a question, we've done some research, consulting prior knowledge, we made a hypothesis. Okay, good so far. It's almost like we could put check marks by this step. One of the things that I disliked about this previous picture is it talks about making an experiment, but you always have to have a controlled experiment. And we'll talk about in class what's a proper control and what variables are and how you control for variables. So you do a controlled experiment. Doesn't necessarily mean that things won't explode or blow up. You can have that happen as part of a controlled experiment. You collect data, maybe put it in the form of a data table or something that you'd write down in your notebook. And then lastly, you interpret it. These three things here, this is usually what the kids enjoy the most. They don't have a problem doing the experiment. They don't have a problem collecting the data. Even interpreting it is pretty easy. You can use some of the things that you learn in math, like a positive slope or a negative slope, to help you decide. Again, though, after we've got all this, you might say, okay, well, what's my next step? Well, you look again at prior knowledge. It comes into play here again. What do you know about what rabbits eat? So maybe if your experiment was, Toby eats more food on a white day than on a blue day. Could you figure out maybe why he does that? And you consult prior knowledge. Toby has to eat every single day, but what's the difference in Toby's world between a blue day and a white day? And the last step that you do here is draw conclusions. So this is your chance to be, a fifth grader or a second grader again, and you get to ask that ever popular question, why? Why did that happen? Now, if we go back here and look at our linear example, here again, you're collecting your data, you're drawing conclusions, and reporting your results. What I think this picture is missing is, follow me as I go to the next one. Check out this arrow right here. The scientific method and the steps of the scientific method is circular, and that's what you have to keep in mind when you do this process. You're constantly making more observations, formulating new hypotheses from the conclusions that you draw. This process never has an endpoint to it. And the example that I like to use is our medicines. We came up with this idea of aspirin and Tylenol a long, long time ago. And based on what we learned about those two very basic medicines has helped us to develop all different types of medicines that help all different types of symptoms and diseases today, just based on a simple drawing conclusions and making more observations. One of the things that you find about scientists is they are always asking the question, why? And I think we can even add to this, they might ask the question, what if? What if they just change that experiment around a little bit? Would they get better results? And they'll go back and test those results. So think about it as a circular pattern rather than a linear pattern. All right, that's what you got to remember. You're constantly going through this process. All right, I do want to introduce to you a couple terms today also as part of your podcast. So just so that we can get these straight, I know that there are all different types of ways you probably learned this before, but we're going to talk about this in some conceptual ways so that we all are on the same part here. So we'll start with hypothesis. What I want you to think about this is it is a guess. All right, it's not just any guess though. It's a guess based on observations and prior knowledge. Okay, now I'm going to flip back a screen because you'll see where we use hypothesis before. We formulate our hypothesis or we make a hypothesis based on observations and prior knowledge. Alright, so this is your guess that's based on your observations and your prior knowledge. Remember, if I'm going too fast, make sure that you pause. Alright, so how do you go from a guess to a theory? A theory is kind of your next level up. Okay, a theory, it is an accepted explanation that stood up through continual testing. Accepted explanation that has stood up to thorough and continual testing. And I'll give you some examples in class as to what a theory is. The last definition I want to get down today, a law. This is a statement of what always happens or always occurs under certain conditions. Alright, so you should have those 3 definitions down by the time you're done today, and I will see you in class where we will learn a little bit more about the scientific method.